Just record.
Okay, it's recording now.
Okay, you gonna run the show, Raul?
Sure. It says, question 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left of z 1.358. Says, round your answer to 3 decimal places. Example, if the answer is 0.8976, then you would enter 0.898 in the answer box. Okay. So that's the
So there's the applet. It's the normal probability.
Danny, what are you playing? I'm playing Murder Mystery too.
okay. So
1.358.
Okay. Did you put in the applet and get the?
I actually I'm having a hard time with this. I don't really.
Let's see here.
That is to the right of the z score. So I've got that open. If we take off everything left of the 1.358, correct?
Yeah.
So it's 0.0872.
On the
Okay,
left.
so you put in. So did you put in 1.358 in the z-scores, and then you looked at and then you
The normal
shaded.
probability. And then I shaded to the right of 1.358. Is that correct?
I'm just trying to see what it wanted in the question here. Hold on.
Wait a minute. I did that wrong. Use the normal applet to find the combined area under the standard normal curve that is to the right and to the left. So I
So
didn't
it'd be
read,
both.
yeah, so I didn't read the whole question right. So both is 0.1745.
Yep.
Did you get that, Raul?
I got 0.175. Is it wrong or?
It's 0. Oh, that's right, because we're rounding it to 3, right?
Yes.
Okay,
Yeah.
Okay.
0.175.
Yep, that's the right answer.
Okay. All right. It says, question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Okay, so let's see.
The polar has smaller if 9 observations are randomly drawn. I would say that can't be determined. I would think, but
What's the question? Which will have the smaller deviation?
yeah, since which will have the smaller standard deviation if 9 observations are randomly drawn from a population.
The standard deviation of a random. Let me come back over here. Where did you guys go? Which of the following will have a smaller deviation? And in the reading, it says that for the mean that draws a random variable mean, blah, 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 blah. The standard deviation of a random variable is divided by the square root of the standard deviation, so that's smaller. So what options do we have?
I think there's a distribution of the sample means. No?
The distribution of the sample means, right?
Yeah.
Wait, the standard deviation of a random variable. Let me.
I don't know. I'm thinking it cannot be determined. But
What in the world?
If a sample mean is normally distributed, then we can consider the sample mean as one observation of a normal distribution with mean and standard deviation. With this in mind, we can compute z-score. The standard deviation mean is always smaller. So is that one of our options?
says the distribution of individual observations, X, the distribution of sample means, and this cannot be determined from information given and no answered text provided.
I would say sample mean.
I think it's the deviation of the sample mean.
Danny,
The
are
distribution
you
of sample
playing murder
means?
or mystery?
Standard deviation,
Yeah.
I think that is that one too.
Might be able to.
Hey guys.
I'm pretty confident that that's the one.
I'm not playing this anymore. Why? Is it boring?
I mean, I'll send the quiz, so I'll
Hey,
I'll
Jake.
tell you if it's wrong or good.
Sorry about that. I got distracted and I spaced it.
Oh, no worries. How are you?
Pretty good.
It said which of the following results implies that the spread in X decreases the sample size.
You know, I'm positive it's the distribution of the sample means.
Yeah,
Good.
we'll roll with that. We'll see what happens.
Okay.
I was thinking it couldn't be determined, but yeah, we'll roll with that.
Okay, question 5. Which of the following results implies that the spread in X decreases as the sample size increases? Normal distribution, the 695.99.7 rule, the central limit theorem, or the law of large numbers?
It's the law of large numbers.
Okay. Let's see.
Wait, let me double check that.
Yeah, I know we did the central limit theorem last time, but that was just saying
The sample size is large. The central limit theorem implies that the sample mean is normally distributed.
Yeah, so it would be. So what's the law of large numbers? Do you have that?
The law of
Definitions.
large numbers, it means that it will become more of a normal distribution.
I believe it was on the preparation, right, for this.
Yeah.
Yeah, I've got it all pulled up. I didn't study as good as I probably should have.
I actually reviewed everything fairly well.
I didn't, but like I just remember because I think it was question 1 or something.
Let's see here.
For the mean of draws from a random variable means only true the mean of.
The sample size is large, and the central limit theorem implies that the sample mean is normally distributed.
Yeah, I would say the law of large numbers as well.
I had the book.
Oh, wait a minute. the spread of the standard deviation of population in the standard distribution. Result implies that the spread, the spread.
Review key concepts. Let's see. Summary.
I really think it's the law of large numbers.
Danny, what game are you now playing? We'll see. What? You can't join me in this if you. How can I join you?
What the heck?
For the sample, it's the standard, or it's a central theorem. I wrote down the definition on the spread, but it's not applying to what the question is.
So, yeah, the spread is sorry, I was trying to do my thing. I wasn't like hearing stuff of what you guys were saying. But I believe the
Why am I
spread
playing
is how
Minecraft?
varied the information is. And I think that the larger the number gets, the more consistent of results
Who's
you
it
have.
not really playing?
Right.
No one.
So
There
I
is
think it's large numbers.
Well, they sure talk about the central limit theorem in this lesson, though. Oh. I'm just looking at the assignment.
For lesson 7,
Yeah. I think it's like answer 12 or something that's talking about that.
Oh yeah. It's is there a theorem that justifies your answer to question 11? What is the name of the theorem?
Danny, what game are you playing?
Sample size and Fourier taken from the right skewed. Those are what is the shape of this? Okay. That's probably not going to apply. Because yeah, that's gonna, normal distribution because of the large sample size.
Okay, so
Yeah, that's what we studied last week.
yeah, in lesson 6, under number 5, the law of large numbers, it says if the standard deviation of the sample means gets smaller, then what happens to the value of X? The value that will be observed very close to the sample size larger. So it's the large number. It's the law
It's
of large.
law of large numbers.
Yeah.
I'll roll with it.
So we're good on that one?
Information to answer the next 4 questions.
Okay, go ahead and scroll down, Raul.
Scores on the quantitative portion of a GRE are approximately normally distributed, which means
Danny,
So question 3 says Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score?
So to get the Z-score, you take 160
Minus
minus the standard deviation, which is 150.8, which is 9.2, and then you divide that by the standard deviation of 8.8, right?
Yes. So it's
1.045.
Yeah.
I believe that's correct.
I got the same thing.
Okay.
Okay. Number 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So we take that standard deviation, the 1.5, plug that into the normal probability applet.
Okay, hold on. I have this pulled up.
And if the chance that they'll score higher than that, so you take to the right of the 1.045, right? And you end up with 0.148.
Yeah.
You guys agree with that?
So you put in that Z-score that we came up with in the first, and then you,
Yeah, you take the Z-score, which is the
Okay.
1.045,
This one.
okay?
plug that into the applet.
Yeah.
Okay, and the question is what's to the right of it, correct?
Yeah, so what's the probability? So,
What's the
Yeah,
probability the randomly will score higher? Oh. So you take
so the
that.
probability be like
Oh, shoot.
15%?
Yeah, it's 0.148.
Yeah.
What are you playing? Natural disasters. Okay.
What was the percent you had?
0.148.
And I'm in the
No,
middle
it's
of a
point-
race.
0.148. That's what he's got written is correct. Right?
Yeah, that's what I got too.
Okay. All right. We're moving along. Can you white? There you go.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the Z-score corresponding to the sample mean of the students' scores?
So let's find out what the mean is of these.
Yes, I survived.
Yeah.
So we're gonna take all these numbers, add them together, and then divide it by
Danny,
5.
Are you playing?
I'll do it in Excel really quick. 1 second.
I got it.
Danny, what's her name? Because I don't see you. I'm gonna play
So that it's 800.
Play
What is it?
the 12.
800 divided by 5.
Uh-huh.
So 160.
Okay.
Okay. So
Yeah,
it'd be the same.
160.
Yeah. So you came up with 160. So that's the mean. So that's kind of what we're looking at.
That's just
So if you notice, this
What's
is 160. So the Z-score would be, it would be the same one right here, 1.045, right?
I believe so. Yeah, because it would be the same.
So it will be the same answer.
It'd be the same answer as number 6. So scroll back
Yes.
up to number 6, Raul.
Yeah, because they were talking about the Z-score for 160.
Okay.
So
Okay,
since the mean is 160 of those numbers, we just kind of referred back to that answer, but it,
Yeah, so scroll back down to number 8 again, Raul. And it says, what is the Z-score corresponding with the sample mean? So the Z-score, so it's asking for the Z-score, right?
Yeah, so it will be the same, right? Because the mean is 160. Okay.
Yeah.
Mm.
It says, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Danny, are you playing it?
Hmm.
Danny, what map are you on?
Probability that the 5 randomly selected students. What is the probability? It's like the probability is 0, right? That they would have higher because it was the same.
Yeah, it would be 5 randomly selected, and I don't know how you would be able to tell probability wise, like if it would be. I mean, I would think it'd be the same chance if you picked 5 random people. Because 160 was the mean, right? The absolute mean.
Yeah.
And that's kind of what we came up with those. So if they picked 5, your chances are pretty good that you're going to be in the mean if you do a random.
Yeah, but just a long.
Okay, so if the sample is 5, timeout. So we've got to take the 160, and then we've got to divide that by what was the standard deviation? Did it give us a standard deviation?
No.
No.
Oh, yes.
Oh, hold on. Let's go back
Yeah.
up here to the top.
So
Actually, this is question number 9, right?
Yeah.
Okay, so yeah, so we got to use that. So the mean is 150.8. So you take the 160 minus the 150.8.
Yeah, it was at 0.9.
And then you divide that by 5 divided by the square root. Or wait a minute. No, you divide that by 8.8, which is the standard deviation, and then the square root of the sample, which is 5. Right? This is an educated guess.
Yeah. No, I get it. Yeah, because the mean is 150.8. It wasn't 160.
Right.
So that
So-
means that question 8 is
9.2. What's the square root of 5?
Square root of 5.
Is
2.
2.23606. And when I was doing this before,
Uh-huh.
I noticed that you've got to go out like 4 or 5 decimals in order to get the right answer.
Yeah, and it says to round to the 4th.
So 2.2360.
61.
61. Okay.
It's 2.2361. So then you got to take 8.8 divided by 2.2361 equals 9.354. And so then you take that 9.2 divided by 9.354, and you come up with 0.9835. So what's the question?
It's saying what's the probability that if you grab 5 randomly selected students, we'll have a mean score that is greater than the mean achieved by the students in the previous problem. The mean on the students previously was the 160, not the 158.
What is the probability that the random students will have a mean score that is greater than the mean achieved by the students? Oh, and the mean is, gosh dang, I got to do it all over again.
So
Okay,
the
but
mean is
that's not a big deal though. So,
I'm kind
no, I know that's what I did, because I took the 160, right? And then you subtract the 160, you subtract the mean, right? Isn't that what you're supposed to do? Don't you subtract the 150.8 from 160?
Yeah, and then you divide it by 8.8, right?
Well, you divide it by the standard deviation, which is 8.8,
Yeah.
Yeah.
divided by the square root of the sample size, which is 5. Right? Let me
Yeah, so you did the value minus the mean, right?
let me go back over to my lesson here.
I'm right next to the volcano. And
Yeah, so you take
don't any damage yet.
the mean minus you take their mean minus the standard mean, divide that by the sample size, or divide that by the standard deviation, divided by the square root of the sample, and that's how you come up with the z-score. Is that what we're looking for, is the z-score?
Well, I think it's asking for the probability. The probability, and I'm almost thinking it's going to be 9. You know how we came up with the score? I'm almost thinking it's going to be like 9.8%.
So the okay, let me plug in.
Because that one number, the number that the previous 5 had was above the mean. Your score was better than the average.
So is the 0.984, is that the z-score? Let me get back over to that. Yeah, so all those numbers I was talking about, that gives us the z-score. And then we're looking for the area that's what's the probability of them being larger? Is that what it asked?
Yeah.
Greater, yeah.
So actually, the probability, when we plug it into the probability applet, so you take the z-score, which is 0.984, and then you go to the right of that.
Yeah, it'd be 16.3%.
No, well, it's actually 0.1626, or yeah, 0.163. So yeah, that's right. 0.163 is the answer.
Yes.
Okay. I'm pretty confident these are right, guys. I think we're doing this correctly.
It says round your answer to the four decimal places.
Okay, which was 0.1626.
Yeah, so it'd be 0.1626 would be the answer.
Yep.
That one?
Yeah, that's right.
Okay. Sweet. Says use the following information to answer the next 5 questions. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of 81 students will be drawn.
81 will be drawn.
Yeah.
So 81's a large sample, so it'd be approximately normal.
Sampling.
I mean, is 81 considered a large sample?
Yeah.
I believe it is. I'm
Okay.
almost positive it is.
Yeah, it's approximately normal.
What the disaster is gonna be?
So normal or yeah, approximately normal, right?
Yeah.
Sweet.
Just so happy.
It says, what is the mean of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that could be drawn for the parent population.
So the sample size is 81. Go back up to the question, or to the information. Okay, so the student is 3.5, the standard deviation.
Oh, it's that.
3.5. Standard deviation is 0.07. That's divided by, mean is 35, and that's going to be divided by,
Yeah, the mean is
3.5, no?
2.5, and it would be divided by
the square root of 81, which is 9, right?
Which is 9.
Instantly died.
No.
What?
Uh,
Danny, what did you die?
0.07 divided by 9.
yeah.
Same with me by
0.0778. So you got 35 divided by that. 35, or I mean, sorry, not 35. 3.5 divided by 0.00778, and you come up with what? 449.87. Could that be right?
I think it's 0.778, no?
No, because you got to go 0.35. That's the standard deviation, right? So that's the top number. That's the numerator. The denominator is the 0.07 divided by 9, which is the square root of 81. Correct? 7 divided by 9.
What is the mean of the distribution of the sample means? For all possible sizes of size 81 could be drawn.
Well, the mean is 3.5, no? Because
Yeah, because I would think, because even here in the information, it says the sample, a random sample of 81. So the mean is 3.5.
yeah, I think
So is that what it's asking? What is the mean of the distribution?
Yep, you know what? You're right. I'm going way ahead of it. I'm figuring out the whole problem, not just the mean. So the standard deviation of the sample means.
so. That's what
So
we.
that's where we're going to do all the calculations, right?
Yeah, that's what we were going with.
What is it? It's a tornado.
3.5 divided by 0.00778.
I just got a tornado.
What is the standard deviation?
We're probably on the same match.
It says it's 0.7 in the question, but
Do you see a guy with crazy hat and a robot? No, because I am
Yeah, the
outside.
standard deviation is 0.7, but the sample size is the square root of 81,
yeah.
right?
I guess they're saying that this is for
At the very top.
this is for all of BYU Idaho. I think is that
Okay.
0.07, that 0.7, and then I think they're saying they're taking a random sample of 81.
Right, so you take that 0.7, and then you divide that by the square root of the sample.
By 9.
I'm heading to the top.
So 0.7 divided by 9.
0.7 divided by 9, yeah, which is 449.87.
Off the cliff.
Wait a minute.
0.0777, right?
Yeah, it's
Hold on.
0.0778.
That's correct.
Okay, give me 1 second. I'm thinking through this.
Okay.
So that's that. 0.07. I did it wrong.
So standard,
So then you
standard
take the-
deviation, that would be
0.07 divided by the 0.00778 equals 8.9974, and then you divide the 3.5 by that. 3.5 divided by 8.9994 or 9974. And you end up with 0.389. So the standard deviation is 0.389.
0.389.
So you want me to walk through that again? And you
Yeah,
guys
I'm
tell me if I'm doing it right. Okay, so the standard deviation of the distribution sample means, so the average GPA is 3.5, right? So that's our numerator. The denominator, you take the standard deviation, which is 0.07, and you divide that by the square root of,
But it's.
no, I still did that wrong. Dang it. You divide it by the square root of 81, which is 9. So you take 0.07 divided by 9 equals, and so 0.07 divided by 9 is 0.00777, and it goes on forever with
zero,
that.
yeah, 0.0777777, yeah.
Okay,
Like,
so then you take the 3.5, divide that by the 0.00778.
okay.
3.5 divided by 0.00778,
But I died.
let's say.
I was with you, but I died.
Doesn't make sense.
45. I'm thinking it's probably that.
Which one is your name?
I'm thinking it's probably that
Not the
0.0777.
same. Why? Mine hasn't ended yet.
I think so too.
I'm in the tower.
I think you go off that sample size. I think we're thinking it too hard. I think it's
I hate
that square root of the sample, and I think you take that and you. Hold on. I had this. I got one of these things wrong. I think on one of the last homework quizzes. And the teacher kind of wrote what I had to do. I'm wondering.
Jake dropped off.
Oh, did he?
Yeah.
He sent an email.
Yeah, he might have another class or something.
I need it.
Yeah, he's got another one that's got to get on it. Thought at 9.
I need a tornado.
My storm has.
At Launchland.
I'm in Launchland. I
Oh,
wonder
shoot.
what this is.
What's your name?
No, it starts with a Daniel.
Are you still alive?
Possible sample size.
Danny, are you still alive?
God, that's tough. I don't know if they.
Danny, did you die? Danny, did you die yet? I think I
Okay, in
just
the summary, it says when the distribution of sample means is normally distributed, we can use z-score and the probability applet to calculate
you died.
proportions and probabilities. A z-score is calculated as, and we've done all that. It was exhausting.
Danny, Danny, did you survive? Mm-mm. No, I didn't.
Hey, why don't you guys go get ready for bed? Okay. Danny, go get ready for bed.
Why?
Because it's almost 9.
It's Jackson gets back. Oh, but
No, you will go and do it. I tell you. Go get ready.
we're in the middle of a match.
I don't care.
Yeah, I mean. So what was the answer? 450 or?
Oh,
I don't know. I mean, it just doesn't look right to me. You know what I mean?
Standard deviation can't be 450.
And that's why I'm looking at this. I mean, they had for the school the deviation was 0.7.
Yeah.
I have to think it would be
oh
close.
shoot!
Why did we put the 0.077?
You just need to go on a ladder.
Is that not?
This is stupid.
Yeah, because I'm working it out all the way to the z-score, and we just need the standard deviation.
So I think that's the standard, no? Like you don't have to go all the way to the z-score.
Mommy, is it here each
So you think it's 0.0078?
I think
I
so,
think
because
it could be that.
I'm just gonna put it.
Yeah, I think you might be right. And I'm taking it beyond that, but 0.0078. No, you need another 0 in front of there.
You think it's 0.07777.
It's 0. It's 0.0078.
So how did you get 2 zeros? I take, I think it was 3.5, right? Divided by,
Mike's lucky man.
or hold on.
No, because 3.5 is
I got
the
this.
mean.
Yeah.
And the standard
It was-
deviation, you'd have to take the 0.07 divided by
The standard deviation is
81.
0.7, I believe.
Danny, did you survive that?
So 0.7 divided by,
is 0.07, right?
I thought it was 0.7.
Okay, go back up.
Lucky, Mark, lucky.
0.7.
Thank you. You know what? That's what it is 0.7. I had a 0.07. You're right. I'm sorry, Ryan. Thanks for catching that. So you have 0.7 divided by,
Divided by 9?
divided by 9.
Yeah, it was 0.0778 probably.
Yeah, so we need 4 decimals. So 0.0778.
Does that sound right?
0.0778. Yeah, that's right.
I just guessed it. For me, it never.
Yeah, I apologize. And so I got that extra 0 because I put an extra 0 in there.
Yeah. Okay, 13. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
So 3.5 is the normal mean. So I think this is where you take that 1 and you subtract it. So it was 0.2.
Fine, I'll sit in this chair.
And then
I'll just sit in this chair.
So you take the 3.5 divided by the 0.0778. So the mean, or so the z-score is 44.987. Is that right?
Wait, what was?
Let's look in here.
Are you on a
it'd
singing
be less than
storm?
3.3.
Listen on me. What?
So,
Help me.
Okay, then you're not in the same map as me. Because I'm in the same room. I'm a survivor.
What? I survived. And now I'm gonna roam around because it's not done. And nobody can stop me from keep doing this. Because everything just got destroyed.
Man, I felt like I had this figured out.
yeah.
I actually studied this for a couple hours before getting on here.
Yeah, no, I'm looking at it and I was like, golly. Do you take the 3.3 and or 3.5, subtract 3.3, which gives you 0.2, then do you divide that by the standard deviation,
Stripper.
which gives me like 28, like 0.2857.
I get that.
27.
Probability of like 28.57%.
That's my escape. Oh.
I don't know. That's a guess.
And you know what? The 0.02 is what it's actually a negative 0.02, right?
No, I just think it would be,
Because you take the 3.3 minus the standard deviation,
Where's your 30?
or minus the mean, which is 3.5. Because the 3.3 is 0.2 minus or less than the 0.5.
yeah.
Okay, so that's our numerator is the
You guys always pick
Negative
the worst
0.02.
map.
I know that makes it
randomly. So then the mean is 0.7, right? I mean the standard deviation was 0.7.
So would you take this number and subtract it from 1 to give you 80 or 72, like 72% probability?
And I'll run away from it.
Probability.
Yeah, give me just
I was
What?
asking for a probability, so it has to be between 1 and, or 0 and 1.
Balloon away, people. We
Right,
need to balloon
0.02.
away.
divided by
Yes, everybody.
0.78.
We're ballooning away.
Equals-
We won't die.
So the standard here, let me get
What?
over. So the
We're
z-score
survivors.
is 0.0257,
Oh, oh,
right?
oh, oh, no, no.
And this, what are the chances? What's the question? Will it be larger? Soon will be less than 0.33.
What? I just got uppercutted by a volcano.
Is it 0.49?
Mr. Volcano. Mr. Volcano.
So what I did, guys, is I took, okay, you take the 3.5 or the 3.3 minus the 3.5, correct? That's
Uh-huh.
2. And then you divide that by the standard deviation, which is 0.7, divided by the square root of the random sample, which was 9. So you take the 0.7 divided by 0.9, which is what we did before.
How did you guys survive
And
that?
then you come up with a 0.7778.
Yeah.
And then you divide the 0.02 by the 0.778 to get the z-score, right? That's how you get the z-score.
Bro now. Bro. Because I look like
So the z-score is 0.02 divided by 0.0778. And your z-score is 257.
it's gonna be a tornado. I'm ready to jump away. Flip a sandstorm.
And if the probability of being less than that number is 3986, 0.3986.
23.
0.3986.
I believe that's correct.
Guys,
Well, it says round to 3 decimal
can
places, so it'd be
you sign all the
0.399, right?
decks? I'm
Yes.
dumb. I'm up here. That clock doesn't work. Doesn't it?
0 point or just 0.3?
0.3.
Like automatically plus the 0.
Yeah. So are you guys following along? Do you agree with what I'm saying?
Yeah, I mean, it's close to what I was, kind of what I was thinking, but
I'm a cat guy.
Okay, what is the probability that the mean for 81 randomly selected students will be greater than 3.3? And it's the same.
so it'd be that minus the other. It would be 1 minus that number, right?
Wait, what's the question? What's it'll be greater than
Flip.
the 3.3? So you take
399.
the
He's 60.1%. So it'd be 0.601.
correct.
Yes.
Yeah, because you gotta add that middle section in there.
On what? 0.
0.601.
5. And then move.
Says the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident.
What has
Standard
happened to
deviation
you?
of passenger weight is 26.7
Have you
pounds.
survived since the
The weights of a
tornado?
random sample of
We
48
found the
commercial boat
survivor.
passengers were recorded. The sample mean was determined to be 177.6 pounds.
Hey, guys.
Find the probability that a random
Hey,
sample
you're done.
of passengers will have a weight
Go get ready for bed.
that is extreme or more extreme, either above or
I
below
hate you.
than what
Put all that in the
the
garbage.
sample.
Go get your pajamas on.
So
Okay, so we take 177.6 minus 185. So our mean is minus 7.4. And standard deviation is 26.7. The sample is how many?
48.
48.
So
Square root of 48 is 6.9282. So we're going to divide the 26.7 divided by
6.928.
Okay, I did 6.928. I took it out 4, and so the denominator becomes 3.8538, and then you divide 7.4 divided by 3.8538. So our z-score is 1.920. 1.9201. What is it asking? What's the question?
That extreme or more extreme means that we are not only interested in
find the
value.
probability that a random sample,
Oh, yeah.
asking pretty much as
Okay, so
And the probability that the random sample of passengers will have a weight that is extreme or more extreme. Either above or below the mean.
above or below.
Yep.
So the probability is 0.0549.
0.0.
Is that what it's asking for?
I think so. Yeah.
I'm doing all the work and I'm not remember what the question. Find the probability. Yeah.
Yeah.
Sample of passengers that will have a weight that is as extreme or more extreme.
It says note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are
That are higher. So we add the bottom and the top. Right? We highlight what's above and below that extreme mean, because that's a pretty broad mean. So it's 0.0549. How many does it want?
3 decimal places.
4.
So 0.055.
It said 0.055.
Yeah.
Is that good?
Yeah.
Well, we should submit this and see what happens here.
You ready?
Like, you got
There
them
you go,
all
Ronald.
wrong.
13. Ouch.
So what do we get? 13 out of 17?
Yeah. Let's
Yeah,
scroll
that's
down
what
and see what we missed.
So that one got real good.
Well, we know we got 1 and 2, right?
Yeah. Okay. Now 8, 9 is where we started getting off track. Ten, 11, 12, and then we missed 13, 14.
So 4 wrong, right?
Yeah. All right, so let's go back to number 8.
You know what, guys? I gotta jump off. I got another meeting I gotta just join.
Okay. All right, we'll just go ahead and Raul, if you'll just post a recording,
I'll do that.
and then we'll just, we can just go back and try and figure out those other 4 on our own
Sounds
before we
good.
submit it, or we just submit it and take the hit.
Yeah.
All right, guys. Yeah,
All right.
that's a tough one.
Okay, we'll see you next week then.
Cool. We'll see you
Yeah,
guys on Tuesday.
I'll post the Zoom on Tuesday.
Okay.
Thank
All
you.
right. Sounds good, Jack.
All right, guys.
Okay.
All right.
Have a good night. Thanks, everybody.